Thank you very much. All right, so welcome to chapter 2. So this is all about visualizing data and mapping data onto aesthetics. It's a really short chapter, so basically what we're going through today is understanding how aesthetics relate to different types of data and understanding the role of scales in actually taking your data and making it visible to the world. So, an aesthetic is anything that describes an aspect of a graphical element. And every single aspect of a plot has to be described as some sort of aesthetic in order to be visible. So, you're going to need to have an aesthetic for everything that all of your data basically, or it will not show. So you can sort of see some examples of what aesthetics are in figure 2.1 of the book. Um, and what the author says is that the critical components that you'll have in pretty much every plot are going to be position. So this is where that element is located in space. For all of the visualizations that we're going to be talking about, these will be two dimensions. So you'll have an X position and a Y position, but you can have visualizations where there's one dimension, three dimensions. If you're working on a 2D surface, like a screen or like a piece of paper, visualizing more than three dimensions is basically impossible. But I don't know, maybe you're making some sort of fancy holographic data visualization, you might have more dimensions. Um, so yeah, we're going to be talking about two positions in our sort of discussions about visualization. Shape and size are both critical components, and those are pretty self-explanatory, as well as color. Color is interesting because when we think about color, sometimes we don't think about black and white as being colors, but for the purposes of data visualization, you do still need to assign them a color value. So, for example, if your background is black, you do need to assign the color white to something, or else it won't show up on a black background. Likewise, if you have a white background, you need to assign something as black, or else it won't show up. If you're using lines in your visualization, then those will also be critical components, and you will have things like um, line width or line type aesthetics. Beyond these sort of six examples, there are many, many other aesthetics. Some examples include the attributes of font, like font face, font size, what have you, as well as transparency. But if you have these sort of six basic aesthetics, you can make a graph. Here we go. When we're looking at aesthetics, there are basically two groups that we can think about. We can think about aesthetics that can represent continuous data or aesthetics that cannot represent continuous data. So just for simplicity's sake, I'm referring to them as continuous aesthetics and discrete aesthetics. Continuous aesthetics can include position, size, color, and line width. These are basically anything that can have a whole range of values with very few intermediates, or not very few, very many intermediates. So you can basically infinitely change these aesthetics. Discrete aesthetics include things like shape and line type. One thing to note is that you can use continuous aesthetics to represent discrete data if you'd like, so you can have colors representing different categories, but discrete aesthetics cannot be used to represent continuous data unless you go through a process of discreti discretizing, that sounds wrong, the data first. So an example of that would be taking like a continuous variable and then binning it to make a histogram. You're essentially turning your continuous data into discrete values, and that would be that would allow you to use discrete aesthetics like shape or line type for those data. When we're working with data, we might encounter many types of data. Data does not only refer to numerical values. We can mean things like continuous numerical values, discrete numerical values, discrete categories like dates or times, or text. When we're dealing with numerical values, we usually call those data quantitative, whereas categorical data are called qualitative. And when we're working with those qualitative data, we have some specific terminology that is used. So if you have a variable that contains qualitative data, the data are called factors, while the different categories within a variable are called levels. So as an example, you might have a factor called animal. So what animal is it? And then your levels might be things like dog, cat, or fish. Within your factor, you can have levels that are unordered. So the dog, cat, or fish example are unordered. There's no sort of logical progression from cat to dog, unless you're working in paleontology, in which case there might be a logical progression from fish to cat, but that's sort of a special case. Um, but you can also have ordered levels. So an example of an ordered level is months, where March comes after February, which comes after January. So there is a logical progression as you go through a year. You go from January to February, March, April, etc. Um, I just copied this here so that people can look at it, but I'm not going to go over it. Basically, it's just a little bit more of a detailed description of what different types of variables are, examples, what type of scale they would use in the description. Um, from our last meeting, it seemed like everybody here is pretty familiar with working with data already, so I'm imagining that this is all sort of old news and I'm not going to go over it. Now, the next thing we need to know about are scales, and a scale defines a unique mapping between data and aesthetics. Scales are always one-to-one, so a specific data variable will correspond to one aesthetic value. So in our previous example, you might have a variable called animals, and each animal would have its own shape on your plot. Um, a possible exception to the one-to-one, where each variable corresponds to only one aesthetic, um, that the author didn't talk about, but I kind of thought of was if you have points on a graph, you might want to map one variable to both color and shape. Um, as a way to aid in interpretation for colorblind readers. So I think that's a possible exception to the one-to-one mapping that I would highlight specifically. Um, One thing to think about is how your choice of mapping, so what scales you use and which variables or aesthetics you map those onto can really drastically affect your visualization. So figure 2.3 and 2.4 in the author's in this chapter map the exact same data. They map temperature by month for different locations in the United States, but they are extremely different visually. And because of this, this means that your choice of scale um, can really impact the interpretation that somebody will get out of your visualization. So the top um, is, sort of the more traditional representation, but it might not give you as immediate of a connection between the different locations at the same time point. Um, So on the bottom, I can clearly see that Chicago is a lot colder than all of the other locations in January. You can see that in the top graph as well, but let's say you were looking at something like March, you might not, you have to do a little bit of interpolation to know what the month, where the month of March lies on that sort of continuous x-axis. So two different ways of interpreting the exact same data, very different conclusions, and both are good visualizations that are, are showing you the data and showing you the data accurately. It's just a matter of what's most important to highlight. The basic visualizations that we just showed generally have only three scales. They've got two position scales, so an X and Y axis, excuse me, and a color scale. But depending on the complexity of the data to be visualized, you may use many more scales than that. The visualization in figure 2.5 has five scales. So we've got our X and Y scales here, as well as a color scale, a size scale, and a shape scale, all representing different aspects of the data. And I never talk about I I hate this data set because I genuinely do not understand cars at all. So every time I have to describe like what's happening with it, I'm like, I don't know what these mean. Um, but yes, basically, color is showing your power. So the lighter the color is, the greater power is in that vehicle. The larger the size of your point, the heavier the vehicle is, and the different shapes correspond to different numbers of cylinders. And that's it. That was the whole chapter. So we breezed through it in a swift 10 minutes.
Yes, that is a very I think it's a very fundamental chapter, and he explained it so succinctly and giving all the examples needed. So I honestly think that this is I do like the way the book is written. I guess that's what I'm trying to say. Thank you, Ashley, for presenting this also so well and succinctly. Um, I think that after seeing this, for example, it makes a lot of sense when you go to R and you start seeing in ggplot how they use, because I never really like connected when they use like the scale function. So they always use like scale fill. What's the other one they use? Scale size, scale color. But now it comes from this, right? Like you're scaling your data on that using that scale, right? Like if it's color, if it's position, etc. So I think that gives it like a little background to that.
Hmm. Yeah, and I feel like, this might be just like from being self-taught and coming from a science background. I had never really learned like what factors and levels are. It's like I know what they are, but I don't think anybody had ever sat me down and was like, okay, this is what this means. I was
Mm,
just like, that's the thing in R that is the name for the thing. And I didn't know that there was like very similarly, like I didn't really know when I was first learning R that there was actually sort of theory behind why they were called that.
mhm. Yeah, categories with levels, and then you can. I always do the factor thing before I graph it, but there's people that mess with the factors when they're graphing it. I always do that like a pre-graphing phase when
Mhm.
I'm ordering the data. That's when I assign the factors and then the order of the factors. That's when I do it. But you're right that no, that sometimes you're just like you think it's an R thing when it's a statistics thing, or it's a concept that comes from statistics, really, right? Like yeah, factors, categories, like text, just categories, discrete, yeah, data. Josh, you wanted to say something? Oh, okay. It's just that you're unmuted. So I thought you wanted to say something, maybe.
Mm.
Oh, still disabled. Yeah. Okay. Um, okay. Anyone else has any comments on the? Oh, Arthur, you wanted to say something? Sorry.
Actually, just kind of like a comment and a question. in a
Mhm,
combo. I guess the comment is that I really like this introduction because it seems like it nicely describes the grammar of graphics. But on the other hand, I do kind of wonder how this hits for people who aren't steeped in this whole grammar of graphics description of data and how
mhm,
this description kind of compares to other data visualization books. I'm an R user and have tinkered with ggplot too, so this is not unfamiliar, but
mhm,
I can easily imagine that, other, like, I don't know how Seaborn works in Python, for example. So I don't know if this
mhm.
quite, I don't know how well it resonates for people who aren't familiar with this grammar of graphics approach. I learned that
Yeah, if
Flourish,
it
another thing, actually uses grammar of graphics,
mm,
but I don't know how
mm.
many data visualization tools actually do.
Yeah, if it translates, you mean anybody else here uses Python that can maybe shed some light on that? Because I'm gonna start actually. So there is this other book club called Pi for Data, and I'm gonna start a cohort soon. So if anybody's interested in starting Python from scratch, I'm not sure exactly when because John is still like tinkering with all that. But if anybody's interested, just FYI, look for that. Pi for D, I think it's called is the channel. So yeah, but if anybody has experience with Python, maybe you can like let us know if this translates to data visualization in Python or any other language.
Yeah, I know we had somebody last week who said they used Python.
I want to
I
say it
don't know
was
if it was
Tim.
Tim.
Yeah.
Yeah,
Yeah, that was me, but I think I'm still I've certainly like heard this terminology before. I think I'm still just like so new to the fields that I don't feel super confident speaking to to
fair
the
enough.
different you know the language that it's using, but I've certainly heard this type of language used along the way in what I have studied. So
Okay.
Cool.
Yeah.
I'm
Okay.
gonna I'm gonna have to like I don't know, force a student to read this chapter and like give them a survey after, be like, did this make sense to you as somebody who's never worked in ggplot?
Yeah. Because I mean, before I started doing all the things in art that I do before I started coding, when I saw this in my statistics class, because we saw factors, we saw integers, we saw all of that before starting. Oh my God, I don't want to say how old I am, but when there was no R before, or it was starting, I should say. So in my undergrad classes, my statistics classes, we saw scales and we did saw like types of variables and things like that, but it wasn't, so the language was not, I wasn't unfamiliar with that language, if you will, but it just goes into a lot more detail, I guess. But we did say, like scale, for example, in my classes, my undergrad classes, scale was something like if it was a continuous or a discrete thing, and also if it was like ordinal or so if the factor had orders and things
hmm
like that. So I wasn't that um, unfamiliar with these concepts from my pre-R background, if you will. But so I guess it does translate in a way to people that are learning another language if they had maybe a statistical background. Yeah, but it would be interesting to see. Yeah, so if anybody else is on the Python train, I highly encourage you to go to the other book club to see if we can all learn in that. It's on Saturdays though. Is that's the only thing, but
Mm.
yeah, that'll be cool. Yeah, I'm definitely going to explore that other Python package that uses grammar of graphics that Arthur
Yeah,
just
me
put in the
too.
comment. Yeah, that sounds super cool.
Yeah, I need to learn Python, but I don't know if I'll be able to do a book club or not right now. So
I know it's a lot.
if
No,
I
I know.
can, I definitely will. But I have to see my fall semester is currently like I don't know what I'm gonna be doing. So it could
Yeah,
be really
no, for
busy or it
sure.
could be not busy at all.
Yeah, exactly, because you haven't really started it, right? It starts in August, I guess.
Uh, yeah, so I'm kind of like it. Yeah, it'll be after Labor Day, so in September.
Mm, September, okay. Okay, anybody else has any other comments regarding this chapter with the scales and aesthetics? All right. So the other thing I wanted to mention is I'm gonna put in the chat. I don't know if you'll be able to access this link because it's one of those like sharing links where you can see a paper that's under like a paywall, but someone shared it using their token. So I'm not sure if you will be able to, but if not, I can always share my screen. But the idea is that this paper came out, let me see, and I think it's very recently. Yeah, in June of this year. And is this scientist called Helena Clara Jambor, and she came up with this checklist for designing and improving the visualization of scientific data, and it's published in Nature. So essentially, the paper just goes through like her top 10 or something like that, like her top advice for scientists to produce these data visualizations. So things that you shouldn't forget, things to look out for, etc. So I feel like there's a lot in that paper that will be parallel to what we're reading on this book. So I was wondering if maybe at the end of the book club, or even maybe mid book club, we can sort of do a comparison of the two, or maybe, I mean, we don't have to do it, but it would be cool to see if maybe she's mentioning things that are not in the book, or vice versa. Because I think, I mean, all the advice that we can get for data visualization, I think that's why we're here, right? So when I saw that paper, I was like, ah, for the book club, that's a great resource.
Yeah, this looks like a great paper. I was like, how did I miss this? It's in Nature. And then I was like, ah, Nature cell biology. Things I don't understand, and therefore I don't follow it.
Yeah, I saw it on Blue Sky, so that's why, because yeah, cell biology, me neither. Like, yeah, that's not, I'm an ecologist, so no. But it was on Blue Sky, so I was like immediately drawn to it, because it's a data visualization. So I'm gonna put it there for, we may get a few good tidbits of advice to improve our data visualization. So yeah,
Cool.
okay. All right, you guys. So if that's said and nobody else has any other comments, what we can do is just end the book club here. And the next week, thank you so much, Arthur, for volunteer to do chapter 3, right? Which is I think I don't remember the name of the
Yep, exactly.
chapter.
The
Coordinate
position scale.
systems and axes.
Coordinate and axis. Yes, thank you. And the next week I will present. So we don't have so far someone for chapter 5. So check it out if anybody's interested. And yeah, that's it. We will meet again next week. Sounds good?
One really quick
Cool.
one, and we can stop recording or continue, but I was just looking at as I was thinking about next week, I was realizing, does the book actually talk about what do you call it? The like grid lines and things like that, and advice on that front? Because I'm not seeing it. That was one thing I found maybe missing, unless it's hidden, it's tucked away in there somewhere.
Hmm.
Oh, so that is, yeah, I think it could be, let me see if I can find where this is. It could be in the sometimes multi-panel figures. No.
Oh, there's a section on background grids, 23.2. Maybe there's
Yes.
other stuff as
That
well.
was just where I was going to.
Mhm. I think they do. Yeah, I think that's the chapter 23, balance the data and the context.
Yeah.
I think that may be it. But they have to talk about that. I mean, well, I don't know if it has to, but it's something that it is part of the aesthetics. I think that's a little bit of like I don't know, maybe there is, I've always thought it's a personal decision because I like graphs that only have like the horizontal grid lines, but maybe there is more to it than just aesthetics. So I'm glad that it's covered in chapter 23. Yeah. The other thing that I was going to say, but I haven't really gone through the entire book, and this chapter 23 just reminded me. So there are many chapters. Another thing that we can do is just clump together 2 chapters per week, because they're very, very small. Otherwise, like in 10 minutes, we're going to be done with a chapter. So maybe this is something that we can explore. I'm going to just leave the idea here, and then maybe we can talk more about it on Slack. And if that's the case, we can let John know. Technically, John is supposed to be listening to the book club, but I'm not sure if he is. So yeah, so that's another idea that we can also like.
I like that idea. Otherwise, it's what, 29 weeks, which isn't terrible, but also if it's going to go fast, if sections continue to be short, then we could go through things more quickly.
Yeah.
Okay.
I'm definitely okay with clumping if we need to. It's always hard to tell at this stage in the book because the first chapter or 2 are usually quite short for most books. So I wonder if we want to sleep on it and see how the next one goes, because the next one it's actually pretty short too.
Yeah, the next 2 or 3 are very short. So okay, let's do that. Let's each one of us go through the book, and then let's talk about it next week or on Slack. And yeah, because maybe if chapter 20 is gonna be super long, then we leave that one just a standalone chapter. But if the majority are gonna be like short like this one, let's just clump them together, aggregate data.
Okay, I'm gonna
Okay.
put stop in the chat.
All right.